The following is a selected video from VideoMathTeacher.com, where you can explore over 10,000 videos, print out practice worksheets, find proofs and discussions on many math topics, and explore related videos. Try VideoMathTeacher.com today. Let's use the product rule and the chain rule to find the derivative of the following function. We're given f of x equals sine cubed of 5x times tangent squared of 2x minus 1. To find the derivative of this, we'll use the product rule and the chain rule on the right. To understand this, the product rule is when we are multiplying two functions, f of x times g of x, and finding its derivative, this becomes the derivative of f of x times g of x plus f of x times the derivative of g of x. Here, we'll write that sine cubed of 5x will be the f of x in the formula, and that tangent squared of 2x minus 1 will be the g of x in the formula. So, to use our formula for this derivative, f prime will become, we'll write down that the derivative of sine cubed 5x we'll write in brackets, that this will be sine cubed of 5x that we'd like to find the derivative of, times g of x will be tangent squared of 2x minus 1. From the product rule, we'll add to this and next write f of x, which will be our sine cubed of 5x, multiplied by the derivative of g of x, which we'll write as bracket tangent squared of 2x minus 1 that we're finding the derivative of by writing a prime symbol. Next, let's find the derivative of sine cubed 5x as well as the derivative of tangent squared 2x minus 1. In both of these cases, we'll need to use the chain rule, which is that when we have one function plugged into another, f of g of x, and we're finding its derivative, we'll find the derivative of the outer function f and keep the inner function left alone inside, g of x, times the derivative of the inner function, g prime of x. In both sine cubed of 5x and tangent squared of 2x, we see that we have a trigonometric function raised to a power. Let's rewrite this. So before finding our derivative, we'll rewrite it in a better form to understand the chain rule. So we'll, instead of writing sine cubed of 5x, let's write this as sine of 5x that we're cubing, that we'll find the derivative of, times tangent squared of 2x minus 1 plus the quantity of sine cubed of 5x, and again, instead of writing tangent squared of 2x, we'll write this as the quantity of tangent of 2x that we're squaring this result, and we'll find the derivative of this function. To find the derivative of each one of these, the outer function will be raising to a power. So, for example, with sine of 5x being cubed, the outer function will be raising to a third power. The inner function will be sine of 5x. So, by our derivative on the right for the chain rule, f prime of x will become the quantity of the derivative of a quantity to a power. The derivative of that power would mean the power would go in front, and we would raise the expression to the next lower power by subtracting 1. 3 minus 1 would become 2. We'll leave the inside function alone, sine of 5x. But we'll need to multiply this by the derivative of the inside function. So we'll write down next that this would be the derivative of sine of 5x that we need to find. We'll multiply this by tangent squared of 2x minus 1, tangent squared of 2x minus 1, and for our other term, this will become, which we'll write on the next line, plus sine cubed of 5x. And again, in order for us to find the derivative of tangent of 2x minus 1 all squared, the outer function will be raising to a power. The inner function is what we're raising to a power, which is tangent of 2x. So using the chain rule here, this will become the derivative of the outer power, which is squared. The power would go down in front, and we would raise the expression to one lower power by subtracting 1. So 2 minus 1 would be to the first power. We'll leave the inside function alone, which will be tangent of 2x minus 1. However, from the chain rule, we need to multiply this by the derivative of the inside function, which we'll write as the derivative of tangent of 2x minus 1. Next, for our next stage, we'll next find the derivative of sine of 5x and the derivative of tangent of 2x minus 1. So, f prime of x now becomes, without simplifying at all, the quantity of 3 times sine of 5x being squared times. To find the derivative of sine of 5x, again, we'll need to use the chain rule. The outer function will be the trigonometric function, and the inner function will be what we're finding the trig function of, which is 5x. So using the chain rule again, the derivative of sine becomes cosine, and we'll leave the inside function alone as 5x. But from the chain rule, we now need to multiply that by the derivative of its innermost part, which is the derivative of 5x, which we'll write as 5x prime, times tangent squared of 2x minus 1. From the product rule, we'll write plus, and our second line will become sine cubed of 5x times, we had 2 times tangent 2x minus 1 to the first, we'll write as tangent of 2x minus 1, but now we need to find the derivative of tangent of 2x minus 1 using the chain rule. The outer function will be tangent, the trig function, and the inner function will be what we're finding the tangent of, which is 2x minus 1. So in using the chain rule, this will be the derivative of the outer function, which will be the derivative of tangent, which we recall is secant squared. But we'll leave the inner function alone by writing secant squared of 2x minus 1. But from the chain rule, we need to find the derivative of the inside function. So we'll write down the derivative of 2x minus 1. Next, let's find the derivative of 5x and of 2x minus 1. So f prime of x is equal to, without simplifying, the quantity of 3 times sine of 5x all squared times cosine of 5x multiplied by the derivative of 5x. We recall that the derivative of a polynomial 5x would be simply 5 times tangent squared of 2x minus 1 plus our second line will become sine cubed of 5x times the quantity of 2 tangent of 2x minus 1 times secant squared of 2x minus 1 times the derivative of 2x minus 1. The derivative of 2x is 2, and the derivative of the constant minus 1 will become 0. So the derivative of 2x minus 1 simply becomes 2. Now that we've completely found its derivative, let's simplify as much as possible. That means that if we have factors like 3 times sine 5x squared times cosine 5x times 5, that the single factors 3 and 5 can be multiplied together and be written in front of our expression. 3 times 5 is 15. We'll return back to writing, instead of sine of 5x all squared, we'll write this more compactly now as sine squared of 5x times cosine of 5x times tangent squared of 2x minus 1. For a second term, we see that we multiplied sine cubed of 5x times 2 times tangent of 2x minus 1 times secant squared of 2x minus 1 times 2. The single factors of 2 and 2 we can multiply and write in front again. So this will become plus 2 times another 2 will become 4. Sine cubed of 5x. Then we'll write tangent 2x minus 1, tangent of 2x minus 1, followed by secant squared of 2x minus 1. So this becomes the derivative of our original function. In summary, this means that the derivative of f of x equaling sine cubed of 5x times tangent squared of 2x minus 1 results in our final answer that f prime of x is equal to 15 sine squared 5x cosine 5x tangent squared 2x minus 1 plus 4 sine cubed 5x tangent 2x minus 1 times secant squared of 2x minus 1.